In the Super Therm coating, we have 4 different kinds of ceramic compounds. 2 of them are basically one is to catch the radiation waves coming from the sun. It catches the shortwave visual light. We have another, our compound, that is a particular micron size that catches the infrared radiation wave. And so for reflectivity, we use these 2 compounds to catch reflectivity, throw it back off, and to help reduce the amount of heat that's absorbed into the coating. We have another, or 2 other compounds in it, or 1 other compound that is a non-conductor, and then we have this compound, which is the 4th one, that acts as a block to emissivity. Has nothing to do with reflectivity. Emissivity is the ability to throw heat off of the surface of the coating, and in our instance also not to load heat into the coating. Meaning that, for instance, this is a metal top right here, and if this metal top, like your car hood, could absorb heat, even though it's a white car, it absorbs heat, so when you touch it, it's hot. Burn your hand. Alright, because it's got density and it absorbs and holds the heat. Piece of paper, you touch it, it's warm, but it doesn't have the density to absorb and hold the heat. This is 50 times lighter weight than a piece of paper. So it doesn't physically have the density to absorb the heat and hold it so that you can feel it, so it constantly throws it back off. And what we're meaning by that is this is a 2,000 degree torch, and we're going to put it right here in my hand. And we're going to hold it there. You can see the red flare from the heat itself. And we've already been there long enough for the heat to start coming through if it was going to load the heat and bring it through to my hand. But what's going on here is that this particular compound physically does not have the density to absorb and hold heat. So it throws it back off to the atmosphere that's cooler than it is. And it does it very quickly, as fast as it comes into it. So one of the things that we want to also demonstrate is when I take the heat off and you see the die down of the red, then given a certain amount of seconds or so, about a minute or so, that was 2,000 degrees, and it was throwing it off constantly. And it did load a little bit right here, but then now we've been about 20-30 seconds, and I can put my hand into the powder and not burn my hand, and it's not hot. So 2,000 degrees, throwing it off, and then it unloads that heat exceptionally fast, and that's called emissivity. Not reflectivity, but emissivity. And that's what we're talking about. So Super Therm works on both angles, reflectivity and emissivity. And emissivity is very important whether you're talking about exterior or interior, because you still want to throw the heat off the surface of the coating. And if it's interior, you're keeping the heat in. If it's exterior, you're throwing it off of the surface. And so that's why Super Therm is as effective as it is, because it does both sides. It's not just a reflector. That's why when it gets dirty, like after 18 years on a test roof that the Japanese have been testing with in western Kansas, after 18 years we only lost 8% of the effectiveness of it because of the emissivity part. It's dirty. It may not be able to reflect like it did in the beginning, but it still does not load heat. And that's why it continues to work. Not because of reflectivity, because of emissivity.